All right, so the last example here is going to be some practice with reading a TXY diagram. And this one is actually from your textbook. It's figure 6.4-1. And it's a mixture of benzene and toluene at 1 atm. So here we have a system where it contains 30 mole percent benzene and 70% toluene at 1 atm, and it's cooled isobarically in a closed container with an initial temperature of 115 Celsius. And we're going to use this TXY diagram to answer a few questions here. So first, question A, at what temperature does the first drop of condensate form? What is its composition? So first, so we have here that it's 30% benzene, so we're going to be working here. So at what temperature does the first drop of condensate form? So the first drop of condensate is going to form here. So if we go all the way up here, it's like 104, 105. So up here, let me just explain for the TXY diagram. Up here, we have vapor. And then here we have liquid. And then here is the dew point line. And then here is the bubble point line. So the first drop of liquid or condensate is going to form here on this line because you have completely vapor, and then here is when the dew point is when the first drops of liquid are going to form. And we were able to get here knowing that we had 30% benzene, and we knew we were operating on the dew point line. So then we just went up here and then to the left, and we get that temperature is 104 degrees Celsius. Oh, and it also wants to know the composition. So the composition is of that drop. So to get the composition of benzene, what we would do is go here to the left and then down. So we know that the composition of benzene, so it's going to be 13% benzene, and then the rest toluene. And then let me erase this so it doesn't get confusing when I do then the next few parts. So for part B, we are asked at one point during the process, the system temperature is 100 degrees Celsius. Determine the mole fractions of benzene in the vapor and liquid phases and the ratio at this point. So here at 100 degrees Celsius, so at T equals 100 degrees Celsius, we have the composition of the liquid phase is going to be like 24%, 24% benzene in the liquid phase, and then in the vapor phase, keep going over here, it's gonna be like 46% benzene in the vapor phase. So we determine the mole fractions of benzene in the vapor and liquid phases. Now we want to know the ratio, so total moles in vapor to total moles in liquid at this point. So we need to take like a theoretical basis. So we're going to take a basis of 1 mole total entering the process. And we know that 30% of this 1 mole is going to be benzene. so we know that we have 0.3 moles of benzene entering the process, or not entering the process, just beginning in the process. And then, so we isobarically cool it in a closed container, and then we end up having a vapor phase and a liquid phase. And so now we have like this vapor phase with 46% benzene and liquid phase with 24% benzene. So let's do a total mole balance first, because we need to figure out how many moles total of liquid phase there are and how many moles total of vapor phase are there. So total balance, we know that we have 1 mole entering the process because that was our basis, and that's going to equal the moles of vapor plus the moles of liquid. Now we're going to do a benzene balance. So we know we have 0.3 moles of benzene beginning at the process, or let me say that a different way. So we have 0.3 moles of benzene throughout the process at all times. That doesn't change. It just changes what composition the benzene is in. So 0.3 moles of benzene is going to be equal to 0.46 times the moles of vapor plus 0.24 times the moles of liquid. So then we use this system of equations to solve for NV and NL, and we end up getting that NV is equal to 0.273 moles and NL is equal to 0.727 moles. So then we can figure out the ratio. We wanted the ratio of total moles on vapor over liquid. So NV over NL is going to be 0.273 over 0.727. And that's going to be 0.375. So that's part B. Now for part C, we want to know at what temperature, and let me erase this again so it doesn't get confusing. All right, so at what temperature does the last bubble of vapor condense, and what is its composition? So the last bubble of vapor condenses. So again, we're at 0.3. That's our mole fraction of benzene. And the last bubble of vapor is going to condense here at the bubble point. So this is completely liquid. So here you have the last bubble of vapor, and then once you get past this point, you are completely liquid. And if we're going in the other direction, that's called the bubble point, because if we're going in the other direction, we would have just completely liquid, and then we would end up getting our first bubbles forming here once we hit this line. So here we're at 30% benzene. We go up here, hit the line. The last bubble is going to exist here. Or another way to think about this is like this is where the first bubbles would form. And go to the left here. And that temperature is going to be like 98 degrees Celsius. And we also want to know what the composition of the bubble is. So now we're going to go here to the right. Wait, I think I'm a little too far down. So here, and then here, yeah. This should intersect here. And then now we go down and read what our composition is. And we see that the composition is going to be 50% benzene. So then we know that the composition of the bubble is 50% benzene, and the remainder, which is another 50%, toluene.